And it survived. My laptop is only at, no, 50%. Okay, it's good. Good enough. It's a gaming laptop. It's old. Yes. What is that? Okay, I'm gonna do this one.
I'll grab this one.
Yeah.
Doesn't wrap, and then I'll make it larger so you can pass that. Yes. Hello, my name is Eric. I'll use my radio voice. Welcome to Cloud Native Rejects. Do you need me to keep talking, or are we good? Thank you. A joke. On the spot. Good grief. Nothing is funny in security and Distroless images. Good grief. But Lewis has a joke.
He spends most of his time trying to convince you how you should remove the stuff from your container images. And once he finally convinces you to do that, then he comes up with the question, but how do you debug it now? How do you use this thing now that I convinced you not to have it? Okay?
Thank you, Victor. That's exactly right. You should break it until it doesn't work anymore and then figure out why it doesn't work. My name is Eric Smalling. I am a solutions architect at ChainGuard. Like some of the other people in the room, I also do Docker stuff with the Docker captains. But we're here to talk about Distroless images. And if you came, who all came from the talk that they just did upstairs? Cool. So this is kind of a follow-on by lucky circumstance. I'm going to touch on what are Distroless images, why would you want to use them, quickly just to make sure we're all level set. And then we're going to get into how to debug and troubleshoot. Not a lot of slides here. We're going to get more into shell and actual practice on this than slides. But let's talk about what are Distroless and why would you want to use them. I'll try not to get feedback because I like to move around. So who doesn't know what a Distroless image is? If you came from upstairs, we got a couple. So it's actually a weird term because Distroless images, even the Google Distroless project, there is a distro. A lot of the things in there are coming from somewhere. The idea is a couple folks that happen to be co-founders at my company were at Google years ago, and they were dealing with problems where people would come to them and say, hey, I've got this Node application, or I've got whatever application, and I'm basing it on, Node from Docker Hub or wherever they're getting it from. And there's all these CVEs in it, and it's coming from, usually, the distro. There's a ton of packages that are coming along for the ride. And the idea they came up with was like, you know what, why don't we just get rid of this, the distro? We don't need it. All we want to do is run a Node application in a container. That's the graphic. But unfortunately, what you're getting when you go to Docker Hub or Quay or wherever, and generally when you pull a general purpose image, you're getting curl or wget or bash. All these other things are coming along for the ride. What you are is a Node programmer, and you want a container to run that, but you're getting that. So their idea is, hey, let's just whittle down just the bare minimums to run just Node or Python or the JDK or you name it. And that's where Distroless came from. It doesn't have a distro. Let's talk some actual numbers here. So if you went out to Docker Hub, and these numbers are from about a month ago when I put this slide together. If you went and pulled the Node 22.9 bookworm image, the full-on general purpose one that you should never be deploying to production, please God, tell me you're not deploying this to production, has almost 1.6 gigabyte in it. It is based on Debian 12, which is fine. It has 618 packages, and these are packages as described by Sift or Gripe. So these include things like apt, npm, and other binaries that it finds, right? So it's got 618 packages, 586 known vulnerabilities in those packages, 10 of which are critical, and 115 high. Now that's because there's the kitchen sink in that image. Again, that is just great for development, great for exploratory, iterative work. There is a slim, most of the Docker Hub official images have a slim variant. Those are slimmed down, as the name would indicate. And you can see that drops down to about 333 megabyte, and it has about half the packages in it. It also only has 67 known vulnerabilities, one of which is critical and one of which is high. So that's better. It still does have a full distro, though. There is a Debian-based distro behind that, and all of the baggage that comes along for the ride with that. If we look at the Google Distroless project Node image at the same version, you'll see that the size drops down to just over 200 megabyte. And it only has, as far as Sift and Gripe know, 10 or 9, depending on which tag you use, packages. The only difference in this one between the two tags is the debug one has a shell. It's for debugging. So just like in the session you might have just come from, you can use that to debug. You use it temporarily, use it in a debug stage, whatever you want to do. But it has a shell in it. That's the difference. There are no. It's very, 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 very slim. It's can be very hard to use because if you need npm, if you need other things at runtime, you've got to copy it all down yourself. You're on your own to do it. You'll notice it still has one critical vulnerability, which was at the time that I did that scan, which is interesting. It's probably a vulnerability in Node itself. I don't know. I didn't go look at it. But it's an interesting thing. But this is a lot easier. Sorry, try not to get a shadow on that. That's a lot more easy to deal with, right? So if your security team says, hey, what's this? OK, let's figure out what it is. Well, can we mitigate it? Can we work with upstream to get it fixed? Whatever. So that's fine and dandy. But one of the problems or one of the challenges of Distroless, again, as I said, is how do I get all my stuff in there? What if I need a database driver? What if I need this? What if I need that? Well, what Matt and Dan, the guys who invented Distroless, when they formed the ChainGuard Images product at ChainGuard, it's kind of an evolution of that process. So the Wolfi-based stuff that you saw that the ChainGuard free tier images are based on, that was talked about upstairs, the concept there is let's make it the most minimal we can, but also make it a bit more developer friendly and a bit more usable, and have a package manager that is SBOMable and scannable and all that kind of good stuff. What we're seeing here is for the same version of Node, or the latest when I did the scan, that was the same version. You'll see the full-on kitchen sink version, the dev version, which has extra tools in it. It's pretty big. It's almost a gig. It has 319 packages because there's a bunch of npm stuff in there that we include because developers are going to need it. But it was 0 vulnerability at the time I scanned that. And we'll get into why it's 0 and how they keep it 0 later. But the latest non-dev version you see is just under 200 meg, 270. Now that is higher than the Google Distroless because we do include some npm modules, some things that just about everyone needs when they run Node. But they're all still at 0 CVE. The way that's accomplished with Wolfi is if you went into the GitHub repository for Wolfi, you'd see all these APKs are getting built. Wolfi is constantly going out and rebuilding from source everything, including in this case the NPM project, the Node project, all the things that are in there, and staying on top of it. And then the images get generated every time there's APK updates. The image runs come along and rebuild it on top, so we stay at 0 CVE. And there's other things they do, and I'm not here to sell chain guards, so that's as much as I'm going to say. But that's, staying on top of it and keeping it minimal is how they stay at 0 CVE. Now, I can't talk about this kind of stuff without also bringing in Alpine, because it's also a great option. Alpine's image at the same time, 213 megabyte, 220 packages, similar reasons, also was 0 CVE at that time. Now, when you look at that, you'd be like, well, even though it's not distroless, why wouldn't I just go with Alpine? And that's a great option. I'm not saying you shouldn't. However, the one thing that I work with a lot of big strategic type big companies, and the reason why a lot of them won't use Alpine, especially like with Node, is because they build on top of muscle C instead of glibc. ChainGuard made a conscious decision when they formed the Wolfi project to use glibc for compatibility reasons. Muscle is fine for most things, but I haven't looked at it lately, but Node themselves actually calls that an experimental image because it's not glibc based and they don't want to try to support different backgrounds. So that can be a challenge and can be something that stops you in your tracks, especially if you have binaries from like legacy apps that you're trying to port on top of. I've run into, it's less and less as we go, but Java applications that happen to have some kind of weird old jar that has a binary that the JNI call out to that happens to be glibc based. That won't work. So can be a compatibility challenge. Anyway, enough numbers. Let's talk about debugging. So that's what you came to see here today. So let me go over to my shell. And I know this is going to be small. I'll grow the font in a second. I just want to show you that this sets the stage here. The scenario is, let's say I've got a Prometheus application, and I have built this on top of a Distroless. I am using the ChainGuard free tier Prometheus image because I didn't want to build one. It is basically Prometheus on top of the Wolfi base, and that's it, right? It's just running Prometheus and whatever it needs. It's been running on my local machine. I'm just running it locally on Docker desktop, and it's exposing port 9090, whatever. And let's say as I'm trying to debug something here, I need to see what's in the Prometheus config, the YAML file that configures Prometheus. I am not a Prometheus expert, so this is not a Prometheus demo of any kind. But let me grow the font up, and we'll take a look. So the first thing, let's make sure it's running and working. So I'm going to go back over to my shell. So here we go. This just opens. So let's see, I got a valid response, this thing. So I know Prometheus is up and running. So it's up and going. But I'm seeing something odd. I have no idea what I would see odd, but that's the scenario. So I want to go look at that Prometheus YAML file. The first thing I might do is do a Docker exec. Is that large enough for everyone? Okay. So I'm going to exec in, and I want to run bash so I can poke around in this thing. Oh, I can't, because there's no shell in this. There's no bash. So, okay, well, let's do just good old sh. Well, that doesn't exist either, because, again, why would you put a shell in your production image, just handing it to a hacker to use against you if he got in? Well, maybe it's not in path. Nope, it's really not there. So, fine, I'm just going to take the image, I'm just going to run it locally and cat that thing out so I can see it, just so at least I can see what's the default in the image. So we're going to run Docker, and this is actually running, I'm just using a demo script that types it for me. Docker, I'm going to take the entry point, and I'm going to change it to cat, and I'm going to cat out that file. Oh, there's no cat. There's literally nothing in bin in this image. So if you're new to Distroless, that might be a change to, something new to you. So what do? Well, the first thing I'm going to show is if you are using Docker Desktop and you happen to have a license for the Pro or Business tier, I'm not going to say you should or shouldn't. I'm just saying if this is available to you, and at many large companies it is because you have to license Docker if you're going to use desktop at a certain size, you can use Docker debug, which is a feature they added about not quite a year ago, somewhere in there, which if I run Docker debug against my local image, It's going to start up, it's a Nix-based sidecar debug type container. It's going to start it up and put it into the context of the container I'm targeting. So I said debug Prometheus, which was the name of the container, and now if I do a PSEF, you can see there's PID1, there's Prometheus running. I am in the same PID namespace. Even though I'm in another container, we're kind of overlapped like a Venn diagram. And sure enough, I can go into etc Prometheus ls, there it is, and there's my YAML file. Yay, I can see my YAML file. It's like, oh shoot, yeah, this is supposed to be 25 for whatever reason. Write that, I just changed it, there we go. So if you have Docker debug at your disposal, use it, it's a great tool. But I don't want to pay for Docker. I have Docker desktop, but I'm not going to be a pro or whatever to you. This is where my Docker captainship goes away because I'm going to tell you what you can do otherwise. So if you have Docker desktop, and a lot of us do, and you can go into the UI. Can I grow that? Yeah, I can, good. And there's that same container. There's a nice file view in here with a little file explorer. So you can go in, and I can say there's etc, and go down to Prometheus, and say open file editor, and it opens a nice little VS Code window, and there's my file. And there's the 25 I changed. And I'm like, oh, well, actually, I wanted this to be 20, right? We'll hit save, ta-da. So that's available to you in the free tier Docker desktop. It's a great little tool. Use it all you want. But let's say I don't do Docker desktop. I'm not on a desktop maybe. I'm whatever. I just don't have that tool. Upstairs, they mentioned another open source project called cdebug. This is a fully open source project that does very much the same kind of thing as Docker debug does without having to have Docker. So I'm going to try execing into my Prometheus image using cdebug. It's a very similar syntax to, dang it, very similar syntax to a Docker exec, right? So I'm going to do cdebug exec with interactive TTY, and I'm going to start a debug container and remove it when I'm done, targeting Prometheus. Oh, permission denied, because of reasons we'll get into in a minute. Well, fine, I'll just do it privileged, because I'm local and YOLO, I can be privileged. So there we go, and now I'm in, and I have the same kind of functionality. There's my process, etc Prometheus YAML, and there we are, and there's that same 20 I edited before. Let's put it back to 10. So cdebug to the rescue. It's a great open source tool. I've got links to all this at the end. Slide you can get at. So cdebug's great. Okay, this was fun. This was great. I'm running local Docker images. That's not my world. I deploy to Kubernetes, and I've got a developer or some kind of local cluster where I'm trying to troubleshoot this stuff. And let's take a look at how I can do it through Kubernetes. So I'm going to deploy this pod. You can see it's using the same image, and it's just going into a local. I'm running kind locally. Okay, it's running, and I just showed immediately, I can't exec into this thing for the same reason I couldn't Docker exec into it, because there's no shell in that container. So, kubectl debug, they talked about that upstairs too. Let's try that. So I'm going to do a kubectl debug, interactive, pointing at demo pod. The container name inside that is demo pod, because I'm not creative. And I'm going to use a BusyBox-based debug image. So I'm going to say, download BusyBox, start it up as a ephemeral debug container, and attach it to that other container. So it's pulling that down. And now if I do PSEF, very similar to before, I am in there. Normal stuff. If you've used kubectl debug, this is not new to you probably, but there it is. I'm in there. However, if I do, let's see, where am I? I'm at the root. If I cd into etc here, there's no Prometheus, because this is the BusyBox container. This is not the Prometheus one. It doesn't automatically mount that root, the file system. So I'm going to go into the proc file system and ls. We know it was PID1 because I pulled the PS on it. So if you do an ls in here, I'm not a Linux admin, so if I say something wrong, throw a brick at me. But you see that root? That is the file system as presented to the process that's in the container. So if I go into root, oh, I can't. Oh, why can't I? Because I am root. Not to use the overloaded term root too much. I am UID 0. But that fake file system link, whatever that is, that's owned by 65532. And because of the way Linux namespacing and everything works, it says you are not allowed in there, you are not that user, I don't care that you're root, go away. So what am I going to do? With kubectl debug, you could get around this by simply, if I could set a user or privilege, I would, but I can't. That's not an option in kubectl yet. But if I used a debug container that had a UID 65532, I would be 65532. So I can create an image with that user as default and just run it. Now, I'm going to go ahead and use the dev tag version of the ChainGuard one because I have it at my disposal, and why not? So I'm going to do that. Now you can see I'm 65532. Make sure I'm in the right context. I am. Now, this is where a lot of people get caught up here, though. If I immediately go to cd etc Prometheus, that is not the Prometheus YAML I'm looking for, because this is the debug container. I just started a container with the same thing. So don't get confused by that. I still need to go into the proc file system and go into PID1. Now, I can get into root. And from this context, from this point of view, I can get into the Prometheus etc directory. And this one's going to be defaulted back to 15 because this is a new deployment. We'll change that to 25, whatever. I can't write it. It's read-only. Why can't I write that? Sorry? Because, oops, let me quit. It's owned by root, and I'm not root. So what do? Well, let's get back out of here and talk about cdebug again. Because cdebug, and I don't mean to sound like a cdebug evangelist, but I love cdebug because they do support, well, let's just try it first. Let's try to use it. It runs against Kubernetes, first of all. You can point it at a Kubernetes context if you have access to it. If you can do kubectl debug, cdebug can attach in the same, it's doing in the background, it's doing the same API calls and do the same thing. But I'm going to get a permission error because it's trying to mount that root proc1 file system and it's getting an error. It supports user, and it will actually create that UID for me in the debug container and attach it up. So we'll let that run, PSEF. Now, I'm not going to go through the minutia because I don't want to churn. I'm still non-root, so I'm not going to be able to write that Prometheus YAML file. I can get in there and look at it now, but I'm going to jump out of here now and show you that cdebug in Kubernetes supports privileged mode. So if you can run this, if your cluster will let you do it, you can run privileged mode, and now, not only am I in the right thing, it'll actually have mounted it as I need it, if I can get it to autocomplete. And there it is. No, whatever, we'll change it to 235. So, cdebug lets you do user, it also lets you do privileged, and you now have remote connectivity into a cluster. Now, this relies on the fact that kubectl debug is allowed in the cluster you're trying to get to. A lot of companies won't even allow it in dev clusters. That's their choice, so that might stop you right there. Talk to them about it. Say, hey, I needed to be able to debug things. Allow it in my debug clusters if you need that. But those are the tools. Let me go back to my slides, if I can find them. And how much time do I get, Victor? Of course not. So I'll leave this on the screen for a minute so you can take a picture if you want. All of this, everything I've done, including the script that were running those demos, those were all actual running. It's just using a tool, are in this repository, along with a copy of the slides and all these links. So we talked about Google Distroless images, the project. We talked about Wolfi being a kind of an evolution of that. We talked about Docker debug. We talked about cdebug. I didn't show it, but Dive. Who's used Dive before? Dive is a really cool tool. It's a little buggy, so if you want to help him out a little bit, it would be great. But it allows you to take an image without starting a container up and inspect the layers of the image and see the file system itself and see what files are changing by layer. That's a great tool. There's a link to it there. I used Gripe for the scans. That's open source. Feel free. I put a few other things down here that I think you might find interesting if you found any of this talk interesting. Matt Moore, our CTO, wrote this blog about the pursuit of declarative image builds. And it's all about repeatable builds and how Distroless kind of came to be and why Wolfi does the things it does with the APKs and how they build them and everything else. And it's a really interesting blog. He also did a podcast on it on how Distroless came to be, and that's where a lot of the stuff I know came from. Both of those are really good things from him. And then Adrian in the back has done 2 videos that are directly related to the tools I just showed you. If you want to see a different example, there's one for using Docker debug and one for using kubectl debug and cdebug, so less long-winded as me. Feel free to take a look at those. And with that, if we have any time for QA, we have plenty. You said I was almost out of time.
Because I know that if I push you, man, you do it well. Okay?
Yeah,
Exactly.
yes,
We
yes.
have 8 minutes for questions. Okay.
I'll tell you.
Heavy metal question?
Hello. So I have a question about the number of vulnerabilities, one of the first slides.
Yep.
Yeah, thank you. When you say like one critical, one high, or whatever,
Yep.
do you mean that those are vulnerabilities where there is an exploit available, or just vulnerabilities where we know is a CVE, but there is no like exploitation going on? Like there's no way of exploiting that vulnerability.
These are the CVVS. Can't talk. The CVE, the criticalities that have been assigned to them by the
Okay, so
by
it's
NVIDIA.
not a real like vulnerability, as in it could be potentially.
It's right. It is a potential vulnerability. Yes.
Okay, cool. Is there some plan maybe in ChainGuard to have a better way of classifying vulnerabilities, as in only classify as critical stuff that can be used, like?
So ChainGuard's point of view is just don't let them be in the.
Okay, don't let it be in the first place.
So
Okay.
yeah, so the way these zeros come to be is everything ChainGuard images, the free tier or the paid tier, whichever, are made completely made by APKs that we build in the Wolfi project from source. So every time a project has a vulnerability fix, that's usually the CVE gets published at the point in time where the patch is released. We already have gotten that notification from GitHub or whatever version, and we've built it. Often we'll beat the scanners to have something out because the APK has already been rebuilt and the image rebuilt on top of it before Trivy, Gripe, Sneak, whoever has even gotten the database update. So our point of view is let's just not have those vulnerabilities in your image.
Thank you.
Mm-hmm.
Anybody else? I think you were first.
Super quick. What was the tool you're using to drive your terminal? It's fun.
It is Demo Magic, and if you go to this link, you'll see it copied in there. I think I gave a reference to where I got it from if you look at the bash script.
Who was next? I saw Kent first there, and then I'll get to you. Okay.
What about ephemeral containers and using those to mount it? Or is that what kubectl debug is doing?
That is what it's doing. Yeah.
So does that mean that you have to enable, there's a certain way you have to deploy things to enable ephemeral containers to even be allowed?
It can be disabled in a cluster, and I'm not enough of an SRE with kube to remember how to do that. By default, if you just did a kubeADM and started up a cluster just like Kind does, they're going to be enabled. But some shops do restrict them. I don't know if it's through RBAC or through admission control, but you can restrict it.
Is Kubernetes debug GA now? Is it available out
Yeah.
code box? Yeah. Okay.
Yeah.
There was
know.
somebody here. Was it you?
You had mentioned some security considerations with the kubectl debug of a pod. I know of things like, access to files, secrets, and such like that would be part of the pod as an obvious security consideration. Was there something beyond that you were referring to, or is it more that type
No,
of
it's
data
just
that you were referring to?
There are some companies I've worked with where it's a blanket. We just don't allow it in any environment, no matter how far down, how far left you go. And that is a choice you can make. But I would